Yo, what up gamers? It's your boy CG Matter back with another Blender tutorial, and today I want to talk about an accidental discovery I made. So somebody in the Discord server asked me something about concentrics, or actually I was the second person to answer, but that's not important. Somebody asked me something about concentric circles, so I was playing around with how do I make this node group that lets me customize it and all this, and I accidentally stumbled across this version. It's kind of the same thing and has this concentric circle kind of idea underneath, but it kind of uses Voronoi and it just looks strange, and I really like the look of it. Additionally, you can render this in a bunch of different ways, so here's a different render. By the way, this video is sponsored by Concierge Render, so once we get to that part, I'll show you how to like render this thing with Concierge Render, but for now, that's neither here, or is that a thing people say, neither here or there? Point is, let me show you how I made this thing. So, we're using Blender 2.92, I suppose. And really, I already messed it up, but really, like most of these things, this is going to be completely material based. So what I'm going to do is I'm going to get rid of everything, and I'm going to add in a plane. Again, we don't need any more geometry than this because everything is going to be material and node based, and we're just going to look at this from like the top down view, okay? Once you have the plane, go to the shading workspace. We're going to go to rendered mode so we can see what's going on and create a material. What do we call this material? Good question. Maybe we should call it something I haven't called it before. You guys know what's coming. I'm calling it Patreon material because it's going to be available on Patreon. So let's start with concentric circles, and then we'll build up to harder and harder, or the more unique versions that I found. So a concentric circle, essentially you want to imagine that you take a perfectly still pond or lake, and then you just drop a rock or a bit of water, and then these circles start propagating. In other words, we have a origin point where this thing landed, and then we care about the distance away from that thing. Those are the two things that matter. Let's actually get both of those in here. So to do this, I'm going to use some texture coordinates. I always like to use object coordinates when possible because they move with the mesh, and it's centered at the origin. So this would be a nice way to, do it. Take this, send it through some vector math. And by the way, if this is your first time with nodes, God help you. This isn't going to be too bad. I'm going to take this and I'm going to look at the distance function, okay? Basically what this does is it takes our object coordinates. These are three-dimensional vectors. They have an x, a y, a z component. I mean, the z is suppressed since this is a flat plane. It takes those, and we are going to calculate the distance between those vectors and the vector 0, 0, 0. Basically, it's going to look at the distance from the origin, where the closer it gets, the closer to 0, and the closer to black it gets, and then the further we propagate, it's going to be white. And this actually gives us both things. It gives us the origin, which we can like change the position of, and it also outputs a distance, right, from this node. So we actually, with a single node, have both these things. So now that we have both of these quantities, let's make it look like concentric rings. If you took a math class before, you're probably going to expect some trigonometry, some sine waves, because a sine wave kind of looks like water. We're going to be using that, okay? Once we have this, we're going to filter it through. So once we have this distance thing, it's now a float one-dimensional value. We're done with like these purple vector slots. We're going to send this through a sine, not to be confused with sine with a GN. If you find yourself sitting at a sine stadium, it's not the same as a sine stadium. One of those is a boring sport. The sine wave is going to take this and send it through this trigonometric thing. Of course, we're not seeing the waves because this has a period of 2 pi. Don't worry about it. Point is, we don't have enough distance going from black to white to actually see what's going on here. So take this, and we are going to multiply basically the input by a big number. And as we multiply it by a bigger and bigger number, you can see the sine wave is going through more full periods or oscillations, okay? Again, basically what this means is the sine wave takes 2 pi to go through a full cycle, so you have to multiply this by 2 times pi to even get to see a full cycle, but the bigger this is, the more cycles it goes through, okay? If I click play right now, I'm going to open up my little timeline, my nice little tucked away timeline. Boop. I click play, nothing happens. Why? Because we evaluated a bunch of things and nothing should change over time, right? This isn't time dependent. So let's actually make it time dependent. So since this is going to be kind of like a video thing we're rendering, I'm going to make it 30 frames per second before we do the thing. And now to actually get this to animate, all we have to do is do a addition, I believe, after the multiplication. So we add, and you can see whatever we add kind of makes this thing animate. The reason this happens is multiplication gives us more oscillations, more periods of the sine wave. Addition is the phase. It just kind of translates it. It keeps the same number of rings, but whatever. What I'm going to type in here is an expression. It's called a driver hash frame. I know I talk about this every tutorial. It's a driver that outputs the frame number. So frame 1 sends 1, 2, 3, 4, 5, 6. Basically, it's now time dependent, okay? But if you take this and divide it by a big number, so it's not going to be as fast, like divided by 100, now we're going 0.01, 0.02, 0.03, right? It takes and divides it by 100. So that when we click play, although it seems that we made it way too slow, you can see it's very, very slowly animating. To make it less slow, I'm going to divide it by something a little smaller, so the smaller denominator makes it faster. And now you can see we have our concentric rings. Two things to note. One, the number we divide by, the denominator, is going to be the speed of this. So by 10 is going to be twice as fast. And second of all, to change the direction, you can either change this to a subtraction node, I think, or just put a negative sign in front of this. So adding a negative is the same thing as subtracting, and this is propagating outwards now instead of propagating inwards, okay? And this is a infinite pattern, by the way. You increase this, you can see it goes all the way out. This is kind of like a hypnosis thing. Trick your friends into, being your slaves or something. Either way, now that we have this hypnosis thing, I kind of want this itself to have a fall off, right? So if you drop a brick, a drop of water in a pond, it propagates these rings. However, it fades off over time. In fact, it does it with a quadratic fall off, I believe. Basically, the point is the ripples kind of don't visibly go on forever. They do technically, I believe, but they get fainter and fainter and fainter. So I want to, change the amplitude to reflect that. Easy way to do this is I'm going to take a map range node. So again, how do we modify this? Well, we already have a distance function, right? So if we were to just multiply this right now, it's not going to give us what we want. But you can see this kind of gives us the opposite, where it's very faint in the beginning and then it gets brighter and brighter and brighter. Instead, we're going to do the opposite. So take this, send it through a map range, so you can see nothing has changed. I'm going to take the output interval. So again, we're sending in information, in this case from 0 to 1, and sending it to itself, 0 to 1. You can take this and invert it, so 1 to 0. This basically says where the distance is 0 in the origin, make it 1. And then as it gets further and further out, closer to 1, make it 0. We just flip the numbers, okay? But you can see this thing basically has a fall off. So if instead I multiply by this quantity, so in other words, we have this whole sine wave that I'm now going to multiply with this map range thing, you can see it's the same thing, but now it doesn't go further out because once it leaves the circle, it gets multiplied by 0, it's gone, donezo. And just in case, I'm just going to enable clamp so that we don't get any rounding stuff. Actually, it doesn't matter. I'm going to disable it. It's actually going to be important to keep it disabled later. So there are our concentric circles. Again, we can change kind of the fall off here. So quick way, just change it to smoother step. That's going to give you a much nicer fade off. Technically, if you want this to be accurate, since it's on a two-dimensional surface, dissipation follows a quadratic, I think, linear? No, quadratic. And then if it's in a three-dimensional world, no, it is linear. No, it should be linear. I believe it is linear, the more I think about it. I think it's, you can think about energy being propagated around a perimeter. This is physics stuff. Don't worry about it. Either way, I don't want it to be physically accurate. I want smoother step. So these are our concentric circles. It's not that many nodes. Hopefully you understand the theory. We can control the position of it, kind of the origin where it gets propagated from. We can control the number of rings. So again, the number of periods that it cycles through. So maybe I can make it like a little less, something like 15, just so that, there's not as much busyness going on. This map range is going to let us affect kind of like the size of this fall off. And, the addition, we already talked about it. That's like the thing that makes it animate, okay? We have all these things. Fine. You can use this for raindrops. You can use it to hypnotize your friends. You could use it to rule the world. But what I was interested in is this tiny modification I did that surprisingly made it look very cool. So I was playing around with adding a bit of randomness, and I'm like, okay, if I want to add in some randomness, why don't I use something like saving the project? Yeah, by the way, I've been modeling toilet paper. I've been outed. Let me save it on the desktop. I'm going to call these rings. Oh, no, missed opportunity. Should have called them rings Patreon. Either way, I wanted to add in some randomness. I decided Voronoi texture is random, but it also has some structure to it. It has these cells. And I said, okay, what if instead of taking the distance from 0, which all this is based on, right? This is the origin point. Why don't I just make it kind of a chaotic thing, okay? So I tried it. I took some vector math. I said, since we're using object coordinates for this, let's also send this through Voronoi texture. Makes no difference, but it's important for this. And I'm going to subtract these two things from each other. I can't quite remember the order. It's one of these or the other. Either way, I took object coordinates and then subtracted away this randomness and plugged it in here. So it's either this or the opposite. I believe it is this. And you can see it created this very interesting fragmented pattern. Again, you can see this, concentric circle underneath. You can kind of imagine it, but now it's only being evaluated at these fragments that exactly correspond with these cells, okay? What does this mean? This means that, one, it looks cool, and by the way, it looks so much cooler when you slow it down a bit. So I'm going to slow it down. Really gives you some time to think about it. And also I want to change the spacing between these. In other words, the period, something like that. And we can mess around with it more. But either way, I just did some Voronoi texture, and I said, oh, you can actually mess with the scale. Like, well, what's the resolution of these fragments? As it gets very big, it should start emulating the original, because as we make finer and finer infinitesimals, it creates the original. But even this looks cool in its own right. So I don't know, I'm gonna reduce it to 15 or something like that. A little less. I want it to be concentric circles, but just low enough that it just kind of looks mainly like fragments. Okay, so this was the key insight. Okay, nothing crazy going on here. You can even change the type of calculation you're doing here. So Chebyshev should give you those stars, I believe. No, it gives you the camouflage. Is it Minkowski that gives you the stars? Yeah. You can come up with a bunch of different variations, mess around with this and that and all that. I'm gonna stick to Euclidean. And wow, this is an interesting way to do smoke, by the way. I didn't even consider that, doing a smooth F1. Either way, I'm going to keep it on F1. I came across this discovery, and I thought this would make a cool looking render. I'm just going to increase this so the rest of it's black. Additionally, I said we could render this in a more interesting way, because basically this is a black and white map that could be used for anything. It can be used to drive metalness, roughness, height, and I decided to use it as a height map, and I'm going to show you how to do that. So again, this is one kind of render. It looks cool, but here's how you do another thing. For this, since we're using displacement, I'm going to be using Cycles render engine. Make sure you're using Cycles, otherwise displacement will not work. And additionally, for the material, make sure that I remember where this thing is. I always forget where displacement is. I think it's in settings, displacement only. Make sure it's enabled. This way, what we can do is for this plane, I'm just going to give it a principled BSDF. It's going to be gray or white or whatever environment it's reflecting. In fact, let me just load in an HDRI here. Why not? HDRI, where are you? This one's a good one. And then film transparent to hide it. Basically, I'm going to take a plane, and I want that to be the surface, and then this whole concentric circle thing that we made, I want that to drive the displacement, okay? So tiny modification, even a baby could do it, no big deal. Take this, mid-level 0, and by the way, if you're wondering why it's not, actually displacing, this is because we don't have enough geometry, right? Displacement basically takes our vertices and brings them up and down dependent on this material information. If we only have 1, 2, 3, 4 vertices, not much to work with. You can either fix this by adding in and I wouldn't recommend this, you could fix this by adding in a subdivision surface and increasing the resolution. The more you have this, the closer it will approximate, what we want. And we need this to have a lot of subdivisions. Because of that, I recommend instead changing to experimental. By the way, experimental feature set, it's dangerous, but one thing it lets you do is it lets you add in a Subsurf modifier, now with adaptive subdivision enabled. So that's only available when you enable experimental. And this lets you kind of subdivide on the fly, giving you geometry only where you need it. And the closer this number approaches 0, the higher and higher resolution this is going to be, and the less weird stretching we're going to get here. So let me set up a basic scene, and then we'll render it and stuff like that. So again, this is using the concentric circle thing. So if we look through LookDev, it's going to show it as a bump map, but also something interesting. And by the way, the reason I didn't enable clamp before, sine wave doesn't just go from 0 to 1 in a wave. It goes from it goes from 1 to -1, 1 to -1. So I believe we should have some negative displacement in some places once we play enough of this. I'm not sure if that's the case, but we might have some fragments going downwards and not only upwards, so it actually caves inwards as well. Either way, I said I'd set up a scene. Let's do it. Camera, view it, go to view, camera to view, and I'm just going to zoom out. And for something like this that's very motion graphics-y, very Ducky 3D-y, I always recommend enabling orthographic because I think it just adds a interesting kind of perspective, pun intended, to the way this thing looks. So I'm just going to set up our camera, and just to make sure we don't see anything else, pass our part out. Now, I think, wow, why did I move it? It's positioned and back where it's supposed to be. Disable this so it doesn't happen again. I think this looks pretty good. It doesn't have much readability. Like, I can't really tell what's going on. It's all super bright. So I'm just going to flicker through some HDRIs and find one with some high contrast. There we go. High contrast lighting. An outdoors one makes it look like there's a sun coming through it. That's actually an interesting look. That looks super... I might just stick with that one. That looks super artsy. I'm just going to try one or two more. Nope. I like the artsy one. And again, this thing is animated. The issue, of course, being it's going to take forever to process, but whatever. One thing I want to emphasize is these fragments kind of look weird, like there's weird stretching going on, and they're not sharp shapes like they're supposed to be. This is normal. Again, the higher your subdivision is, right, the closer this is to 0, the more this will be fixed. But by the way, right now we have this at 0.5. We are viewing this at a 4, so as if this was the number 4. In other words, when I hit the render button, it will have a lot more geometry. So I'm actually going to increase this, and you can see it looks super garbage here, but let's see what it looks like here. It might even take a moment because we're adding so much geometry. By the way, there was recently a Blender patch that I think makes it so you don't have to calculate this BVH every single time, but that's neither here or there. You can see these fragments here are, I mean, we could lower it a bit more, but you can see this is much sharper than it was in the viewport. And I think what I was saying is true. You can see some of the extrusion, some of the displacements actually going inwards, kind of like it's caving in like a cracked floor or something like this. But let's just like do some final touches on this and send it to render. I mean, again, I don't have much of a plan. I didn't have much of a plan for this tutorial. It was just like a tiny thing I found, and I'm like, this is cool. I'll share it with the boys and girls, but statistically more boys for my channel. I mean, it'd be nice to get more girls. Why not? So I'm lowering this so that when we render, it's going to be more intense. Since we're sending this to a render farm, namely Concierge Render, this is sponsored by Concierge Render, I'm going to do a couple like scene modifications just to make sure it's ready. First of all, cleanup, just delete unused data blocks. This will get rid of any images, meshes, whatever, that are not being used. We have 5 images because there were 5 HDRIs we didn't like. Additionally, go to, and do this or otherwise it will not work, external data, automatically pack into blend. This is so that the HDRI or any assets are actually packed in here. So they're part of the blend and we could send it. So now that we have our blend done, or actually I guess we should set kind of an output, I don't know, 400 samples should be plenty, adaptive sampling, and we don't need this to go for 250 frames. Let's just sample this. I don't know, something like 160 should be fine. Now that we have this set up, let's hop over to Concierge Render, and I'll show you how to render over there. Oh yeah. And we're back. I mean, it's later in the day because I took a break during recording, but you can see the light has left the window and now I'm just left in the darkness. But there is one light in this abyss, and that is Concierge Render. So yes, this is a render farm. It's sponsored, but it actually is a great service, and I use this to render a bunch of stuff, personal projects, short films, stuff like this. So Concierge Render, it's a Blender render farm. If you sign up and make your account, there's a link in the description. You can get $5 in render credits for free, but let me just show you how to make it. So you make an account. I already have one. You sign in. I only have $15 left in my account. You know, back in the day, I had like 150, and then I just kept doing render projects, and it gets whittled away and away. And anyways, once we're in Concierge Render, let's upload our blend. So you go to Upload and Launch Renders. You upload your file. Again, we made sure to, and let's find that file in my mess of a desktop. We made sure to do the two things, like clean up the thing, clean up images and stuff like that to get rid of it, and pack it. It's been a while, okay? Just do the two things I described and upload the blend. You should see that there are a couple megabytes here. Most of this is the HDRI image that was packed into it, okay? So this blend has everything we need. Once you upload it, which is pretty quick in this case, you go to Actions, you go to Launch Render, and sometimes it will, take a second to process. This time, it was ready. Couple things we need to check off before we render this thing on the cloud render and Concierge Render, and we download it. Couple settings. One, render platform, I use 2.92, so that should be fine. If you use 2.93, you can still click 2.92. It works. Blender 2.92, we want cycles because we have the displacement and all this. That's why we're using a render farm. It's very intensive. Render type, animation. This just says render frames 1 to 160, not just one still frame. Frames and resolution, you can see it pretty much imports all our settings, but we could modify these here if I only want the snippets of this, but I do want 1 through 160. Native resolution is my 1080p, 400 samples, good to go. Finally, hardware. This is where, the controversy stirs up. Do you pick this one? This one? Basically, when you put this thing on Concierge Render, you can pick, do you want something to render somewhat slower, but it costs less, or do you prioritize your time and you want like the highest end GPUs, stuff like this, but of course it's going to be $6 per node per hour. So I recommend just keeping it on default. I haven't had any issues with it. So you hit render, it's going to think about it, and then we go to the job manager to actually see the progress. So these are all the renders I've done before. View details. Okay, so again, what's happening here is we've uploaded our blend. It's going frame by frame by frame parallel-wise. I think it does multiple computers at the same time. And the point is, even if you have a high-end PC like I do, it should render significantly faster. So first it does the pending, then it does the calculating, and then it does the rendering. So in a bit, you can actually see what the price calculation is. So you can make sure that you're not over, or I guess underspending would be a good thing. I'm just going to cut to when more of this has finished. Boom, render just finished. I have all 160 frames, and here you can see all the stats of this render. So we started it at roughly like 9:41 p.m. Now it's like 9:51. So 10 minutes for 160 frames with like a heavy amount of subdivision and displacement and all this. Really not too bad, especially when you compare it to using like one computer, like running all of these like serial-wise concurrently. Additionally, you can see this render costs like $11.50, which again isn't that much for 160 frames and all this. But if you're the kind of person who either has a low-end computer or maybe even have a high-end computer, but you need your render to go a bit faster and you don't mind spending a bit of money, Concierge Render, it exists. It's a good option, and link in the description to get $5 in free render credits. So hopefully you learned something about concentric circles and Voronoi, and while I do this, let me put myself on the main screen. By the way, if you want to download all these, you could do it one by one like a maniac. Just click download outputs and it will put it on a zip file. And now for the main cam, hopefully you learned something about the nodes and the displacement and all this, and yeah, that's it for this tutorial. Thanks.